Alright, this is Yoel. My chapter was chapter 7. It's going to be on DNA structure and replication. Alright, starting off, we're going to have DNA. Chromosomes are going to be made up by DNA, and then the DNA structure is going to be a double helix, and that double helix is just going to be a spiral structure. Alright, and then DNA replication. So for DNA replications, the two strands are going to be complementary strands, meaning they're going to be very similar, and they're going to be puzzled like pieces, so they're going to fit together very well. Alright, and then starting off the DNA replication, we're going to have helicase. Go ahead and unwind the helix of the DNA, unzipping the entire thing. Then we're going to have the ligase. Is going to come behind. It's going to go ahead and link these Okazaki fragments from 3 to 5. And then we're going to have the DNA polymerase. That's going to build a new strand of DNA along each of the unzipped DNA strands. So that means that they're going to be semi-conservative. It's going to be half new and half old. So it's going to be half old DNA and then half new DNA. Alright. And then the polymerase chain reaction, or PCR for short, is going to be similar to the DNA replication, but it's going to be taking place in test tubes because scientists are going to use this as a method to go ahead and replicate DNA. And then they're just going to start it off with a small sample of DNA. They're going to add in nucleotides. Then the DNA polymerase enzymes and the primers are going to bind to go ahead and begin replication, and they're going to start it by heating DNA to separate the strands. Then they're going to cool it to allow the primers to associate with the DNA, and new nucleotides are going to be added by the DNA polymerase, and then that can create billions of DNA copies. Alright, so on the next slide. Alright, so there's going to be more information on DNA. So we're going to have genomes. It's going to be a complete set of genetic instructions encoded in DNA. And then we're going to have short tandem repeats, or STRs for short. It's going to be blocks of repeated DNA sequences found at points along our chromosomes. They're going to be non-coding, so they're not going to have any special instructions to do anything. And then lastly, we're going to have gel electrophoresis. And then this is going to be used by scientists to go ahead and separate the replicated STR. And this is going to be used a lot in DNA profiling to go ahead and find people and cases and such sorts. They're going to go ahead and start off the DNA, the gel electrophoresis, by putting the DNA in a gel, and then they're going to run an electric current through it. And since that DNA is going to be a charged molecule, it's going to move through that gel. And then the STRs are gonna, and then the shorter STRs are gonna travel along that current. And then when visualized fluorescence, that's gonna allow them to know to go ahead and separate the segments of DNA, and then it's gonna create a specific pattern of bonds for each unique person. And that's how they're gonna create a DNA profiling to go ahead and profile somebody. Alright, so that was my chapter 7. Hope you guys enjoyed.